All right. So in the last class, we wrapped up chapter 9, which was the periodic table. And now we're going to go back and do chapter 3, which is bonding and structure. So we've already done chapter 1 and chapter 2. I will move ahead to chapter 9, sorry, because it would be better to have an understanding of the elements and how they're arranged in the periodic table according to their atomic structures, to be better able to understand bonding. So this is chapter 3. Bonding and structure. And in this chapter, we will be talking about three different types of bonding: ionic bonding, covalent bonding, and metallic bonding. And you will see that because we've already discussed the periodic table and we also talked about balancing equations, right, at the end, that it would really help us in understanding what's going on in bonding and structure. So let's start off with ionic bonding. So ionic bonding is the kind of bonding that involves the transfer of electrons. And this is something we've already been introduced to, right? And we know that metals lose electrons and non-metals gain electrons. And so in that regard, in general, ionic bonding occurs between metals and non-metals. All right?
Yes.
Now, for the core syllabus, students are expected to know or be able to show bonding, and when we get to that, right, how to show it, but they're supposed to be able to show bonding, ionic bonding between elements of group 1 and group 7. Whereas for the extended syllabus, students should be able to show ionic bonding between any metal and non-metal, right?
Yes.
Now, right, ionic bonding, as I mentioned, right, is only one type of bonding. So, right, if we just backtrack to some more introductory statement, right, we've learned that elements, right, are made of atoms,
Yes.
and those atoms of different elements come together to form compounds, right? I'm writing molecules over here because, right, compounds always have molecules. Elements, right, have or may not have molecules, right? So those are elemental molecules, right, such as oxygen, which is a diatomic molecule, right?
Yeah.
So elements have atoms, and those atoms come together to form different compounds. Again, we are not talking about mixtures at all, right? Mixtures done. We're not talking about any mixtures, so do not confuse that. We're talking about compounds, right? Compounds formed, right, through chemical reactions.
Which react, rather.
Right, and right, the way they come together, they bond certain way, right? The atoms of the elements, they bond in certain ways, right? And they end up with particular structures,
A new compound.
right? And the type of bonding also affects their properties. right? Both physical and chemical.
Yes.
Okay, so coming back to ionic bond, right, takes place between metals and non-metals in general. So, right, what's happening? We know that it's a transfer of electrons. So, a very simple example is sodium and chlorine, and they react ionically, right? They have a chemical reaction and form ionic bonds to form sodium chloride.
Chloride.
Question is how? So you need to look at their electronic configuration. Electronic configuration for sodium is 281. Na, it has 11 electrons. 11 protons means 11 electrons as well, which means it has only one outermost electron. The electronic configuration is 281. Right? And then you've got chlorine, which is 17. Right? And so you have 2, 8, and 7. It's got 7 electrons, its outermost shell. And so we know, we talked about, right, that it is easier for chlorine to accept an electron than lose 7 of them. And right, it is easier for sodium to lose an electron than gain 7 of them. And remember that when reactions occur and molecules are formed, right, it is the end goal, right, of all the atoms to achieve stability. And that stability refers to, right, their valence electrons. Electrons in their outermost shells, right? They need a complete shell, right? Now, whether they achieve that by losing an electron, so you remove that, right? Well, I should not put minus over there, it will cause confusion. So if you remove the one outermost electron, you are left with 2 and 8, and that is a complete shell configuration. And right here you're gaining one, and you will end up with 2, 8, 8, comma there, right? And that is also complete shell configuration. Okay,
Yes.
and so that is the end goal. So how does this happen? To take a look at that now. Make a crude drawing of the atoms over here. Right, that yellow in the center is the nucleus. We don't need to tell how many protons and neutrons there are. This is the first shell, uh, second shell, third shell for sodium. And then you have nucleus for chlorine, and this guy has right, 3 shells. And so what you're doing here, this is sodium with the 281, and this is chlorine with the 287. And you draw what is called a dot and cross diagram. And what that means is that you represent the electrons for one of these atoms with crosses. So let's do crosses for sodium. So you've got 2 over here, and you've got 8. And remember that, right, then you've got 8 electrons, right, or X number, right, they are coming in pairs.
Yes.
And then you've got 1 outermost electron over here. And then for chlorine, you've got 2. Oh, sorry, this one's supposed to be the dot. You've got 2 here, and then you've got 2, 4, 6, and 8, and then you've got 7, right? So how do you pair them up? Well, you make 4 of them initially, and then you start pairing them up, and you'll be left with one that is all alone. Okay, so that is called a dot and cross diagram. And then you know that electrons are being transferred, so you show that transfer, right? So this is the outermost electron, and it is being transferred here to the chlorine atom, right? And so I've drawn it rather far apart, right? But right, that's how you do it. And when that's done, now what do you have? Well, redraw it, but this time with the difference in electrons. Yeah. So the nuclei for both, and this time sodium will have only 2 outer shells. Chlorine will have 3, as it did. And why does sodium have only 2 outer shells? Because it lost the electron that was in its outermost shell, and so that shell is no longer there. It's not going to be, oh well, there is a shell, but it's empty. No. Okay.
There is no use of that shell if there is
Well,
nothing
the shell, there's no electron, so there's no shell, right?
Yes.
And so you don't draw it either, right? Because now you want to show the stable configuration of the atoms, right? The new configuration of the atoms. So you've got 2 over here, and you've got 8 over here,
Yeah.
right? And then you've got 2 and 8. Oops. Dots, 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 dots. 2 and 8 and 8, right? But what we'll do over here for these 8 is, right, we'll draw 1 dot and 1 cross. And why we're doing that is to show, well, this is not actually chlorine's atom. Sorry, electron. And also square brackets over here. And you're going to show the charge. Remember we talked about the charge on the ions back in the chapter 2, I believe.
Yeah.
Right? When electrons are lost, then the atom has a positive charge because the number of protons is greater than the number of neutrons.
Yeah.
Right? And when the atom gains an electron, the number of electrons is greater than the number of protons, and so there's a negative charge.
Yeah.
Right? And so what's happened now is for sodium, right, the number of protons equals to 11 and the number of electrons equals to 10, right? And so, right, plus 11 minus 10 equals to plus 1, and that's the charge in sodium. So you write plus 1 or just plus, right? A single plus sign just shows it's 1. You don't need to write it. And for chlorine, right, the number of protons 17, the number of electrons is 18, and so you've got plus 17 because protons are positively charged, minus 18, and so you have a negative 1 charge. Okay?
Yeah.
And that you have now NaCl, right, which is now ionically bonded to each other. And what's keeping them together in ionic bonding, right? Remember in physics we talked of, when we were talking about forces, we mentioned electrostatic forces. It was just a mention.
Yeah.
Right, so that is the force of attraction or repulsion.
Between magnets, I think.
No, not magnets. That's magnetic forces. Repulsion between, right, electric charges. And so what you have over here, you've got sodium with a positive charge and chlorine with a negative charge, and positive and negative attract. And so that
And they're in
attraction,
physical.
the electrostatic force that is now present between the atoms of these two elements is what is forming the compound for sodium chloride. And it is a strong bond, right?
Yeah.
Okay. Now, right, the dot and cross diagram or dot and cross diagram as it's written in the text. Sorry, diagram. Right, you need to simplify. And so,
Just before we move on,
huh?
basically here, just before we move on,
Yeah,
basically, sodium here lost an electron while chloride gained an electron,
not
right?
chloride, chlorine.
Chlorine, sorry,
Yeah,
right?
yeah,
Okay.
yeah.
So when one of them like gains an electron, we represent them with the negative sign, right?
Yes,
And when one of them loses it, you represent it with the positive sign.
yes.
Okay. Yeah.
Okay, now as I was saying, these dot and cross diagrams are very complex because we're showing all the electrons that there are. And that
Yeah.
makes it difficult to draw every time, right? So you need to simplify. So, right, since you know that only the outermost electrons are involved in ionic bonding. Ionic bonding. And so what we're going to do to simplify this is draw the dot and cross showing only the outermost shell, the valence shell, not sodium, right?
Yeah.
And that's chlorine, and that is the one outermost electron for sodium, dots, not crosses for this one, and that is the outermost shell for chlorine. Right, so this is sodium, chlorine, and then you're going to show the transfer. And now what you're going to do is you're going to write Na plus. So sodium has a positive charge, and for chlorine, right, you are going to show the shell. But you got tongue twister. So, right, the nucleus, that, and right, 2 and 4 and 6 and 8, and you put the. Now, why did we do this? Right, this is the simpler, and this is basically how you want to draw. Okay, so the simplified version showing only the outermost electrons, the outermost shell with the outermost electrons. Now, question is, I drew the outermost shell for chlorine, but not for sodium. I just wrote Na plus. Why?
Maybe because the whole element is being involved.
Hmm?
Well, I don't know. Maybe because the whole uh, element itself is being involved in this compound.
I mean, yes, it is, but remember what we did over here?
Yeah.
Why did we only make 2 shells for sodium later on when the electron was
Because
lost?
the first shell got empty.
Exactly, right? And so in the simplified diagram, we're only drawing the outermost shell. So when
Yeah.
sodium loses its outermost electron to chlorine,
It doesn't have anything left.
exactly, but the element is still there, right? I mean,
Yeah. The
all of the
nucleus is still there.
all of this is still there. It's not just a nucleus; it still has 10 electrons,
Yeah.
right? But again, we're not going to draw those 10 electrons. Okay, so we just write sodium, and it's got a positive charge because it lost 10 electrons. And because chlorine has the outermost shell with 8 electrons now, and so we draw that. Now that's how it's done. Okay.
Okay. Yeah.
Okay. So this is called ionic bonding, right?
Yes.
And right, the book gives you the definition of an ionic bond, right? Pretty much what I've already told you. So an ionic bond is a strong electrostatic attraction attraction between oppositely charged ions. Okay, that
Yeah.
is what an ionic bond is, right? And when that happens, it's called ionic bond.
Yeah.
Okay.
Okay.
Now the book also mentions in this particular part, right, oxidation, reduction, and redox. But I do believe that is something we've already done in our earlier classes, right?
Yeah.
So just as a review, because it's given in the chapter, right? And if you recall, tell me what oxidation means.
When an element gains oxygen. Oxygen. Wait. One loses the oxygen and the other gains it.
Well, oh right, we've done it in terms of oxygen, right?
Yeah.
Okay, so there's another, you know, we could say, what's the word I should use?
Gas.
Another way oxidation reduction can happen, right? So we've talked about oxidation being, so what you said is correct, right? So an element or a molecule or an atom gains oxygen, that's oxidation. So that's correct.
Oxidation. Yeah.
Over here, right, is when electrons are lost, right? Or oxidation involves the loss of electrons.
So which
And
one's correct?
which one is?
Which one's correct? Like
Both of them are
this,
correct. It depends on what's happening. And so, right, if oxidation is the loss of electrons and reduction is, right, is what?
the loss of the oxygen.
Well, loss of oxygen in terms of oxygen, or when electrons are gained. And so, right, in the earlier chapter, we talked about redox, which is, right, when ox,
One element gains it and the other loses it.
right, when reduction and oxidation are happening in the same reaction,
Yeah.
right, are happening simultaneously, or in the same reaction, right, or process.
Yeah.
So
So
yes,
why? Why is it in chapter 9 there's a different meaning and chapter 3 there's a different?
In chapter 9 it was different because, right, oxidation can be defined in, right, three different ways actually, depending on what's happening, right? So to, bring what we've done so far, oxidation is either gain of O2 or loss of electron, right? And reduction is the loss
Loss of
of
O2 or gained electron.
this. So in terms of sodium chloride,
They're gaining and losing electrons.
well, yes, but, right, we just did that, right? So we know that Na plus Cl, right, goes to Na plus and Cl minus. So the sodium has lost an electron, the chlorine has gained an electron, and so in those terms, sodium was oxidized and the chlorine was used.
Reduction.
And, right, this concept of the loss and gain of electrons and, the terminologies of oxidation reduction will come in handy later on, right?
Okay, yeah.
Right, especially, for example, we talked about transition metals, transition elements. And so, for
Yeah.
example, in a reaction, right, we've got iron 2 going to iron 3, which means it lost an additional electron, which means it was oxidized,
Also,
right? And if, for example, you have copper 2, sorry, copper 2 going to just copper 1, right? That means it gained an electron, which means it was
which means reduction.
reduced.
Yeah.
Okay, so if I write it
Yeah.
out over here as Fe3 plus, oh sorry, 2 plus going to Fe3 plus and copper 2 plus going to just copper plus. Okay,
Yes, sir.
right. Now, in the textbook for the extended syllabus, they've, right, mentioned, given reactions for magnesium oxide and calcium chloride as well. So because we've already done the dot and cross, right, I'm going to take you to the book and show that to you, right? Does that
Yes.
work?
Yeah.
Okay, let me just put that on screen. Right, so we've talked about sodium chloride, and see, they mentioned that extended learners should be able to do this for any metallic and non-metallic elements, including dot and cross elements. Right, so something to practice, but as far as, going over the content of the book and syllabus coverage, here's magnesium oxide. Now again, right, magnesium is in group 2, that means it has 2 outermost electrons. Oxygen is in group 6, so it has 6 outermost electrons, right? This guy is going to lose 2 of them. Oxygen will take both of them, and these are only the outermost electrons, right? So the outermost shell. And when the reaction is done, just like we did with sodium, we're only going to write magnesium in the square brackets, and this time 2 plus. The charge is 2 plus. Why is it 2 plus?
Because it gained two of them.
Not gained, it's a positive charge.
Sorry, it lost two of them.
Yes, lost 2 of these atoms, right? And because, right, and so the outermost shell is now empty, so we're not showing it, right? Again, the outermost shell is empty. It's not that magnesium is no longer there, it's still there. right? And so
Yes.
oxygen's gain 2 of the electrons of the outermost shell with the 6 dots for the electrons from oxygen, and the 2 that it gained from magnesium are shown as crosses to, you know, be clear that, well, these are the electrons that oxygen got from magnesium, right? To be
Yes.
clear in our representation. And the formula is magnesium oxide, and right, we call that at the end, well, when we were talking about uh, transition metals and all of that, I covered the crossing over method, right, for equations to understand how many atoms of each element are required in the reaction,
Yes.
right? And so, right, only one atom of magnesium is required to react with one atom of oxygen because this guy is losing two and this guy is gaining, and so it's Mg. And then you have calcium chloride, right? And in this case, calcium is also in group 2, that's 2 outermost electrons. And you can notice, right, that the atomic size that they've made for magnesium is smaller than calcium. And that obviously has to do with the periodic table. As you can see, calcium is lower down in the group, right? Can you see that?
Yeah.
So calcium is lower down in the group, and so its atomic size is larger. And so they've actually uh, represented that in this particular diagram. Not something that you have to be careful about when you are drawing the dot and cross, right? But that's something to notice. Now, calcium is losing two. It's reacting with chlorine. Chlorine is in group 7, so as you know, it just needs one electron. And so calcium is losing two. Chlorine can only take one, right? And so they, right, two atoms of chlorine will react with one atom of calcium, and each of the chlorine atoms will take one of the electrons from calcium. Okay, and so this is what you're going to end up with. Again, calcium's outermost shell will become empty. It will have a charge of 2 plus, right? Because
Meaning it will lose two electrons.
it has lost 2 electrons. And in this case, you're going to draw the two atoms, not just one atom of chlorine and write 2 minus. No, right? You're going to
Yeah.
draw both of the atoms of chlorine, showing the complete outer shell with one electron coming in from the calcium and a single negative charge on each, right? Don't do one and then write a charge of 2 minus. Okay?
Okay. Yes.
And right, so the formula for calcium chloride is CaCl2. Okay?
Yes.
Okay. Something to go further, we'll just end class. And so now it's going really slowly. Right, so the next topic is ionic structures, which we will do in our next class, which will be tomorrow.
Yes.
Okay?
Yeah.
Uh, all good so far?
Yeah.
Right, any questions?
No.
Okay, then I'll see you in tomorrow's class.
Yeah. Okay.
Okay.